now that we know Newton's second law, we're able to connect dynamics with kinematics using the Newton's second law equation, F net equals ma. You'll also see this written a couple different ways. You might see it using the epsilon. The sum of forces will be equal to the mass times the acceleration. Or you might see it written as acceleration is equal to this. This is how it's written on the AP Chemistry or AP Physics equation sheet. The reason it's written that way is to show that the acceleration is really the effect and the force is the cause. Okay? But I always find that this is a simpler way to express that. So let's use that in this sample problem right here. I've got a force being applied at an angle of 30 degrees. We're able to figure out all of our forces now, and we should be able to figure out a net force. Then we will also be able to figure out the kinematics of this situation. And we'll just do a little bit of that. So let's list out our variables right here. Let's make a nice list right here. I've got my F1. I'm going to have my F in X, my F in Y. I'm going to have a force of gravity. I'm going to have a force normal, a force of friction, and an F net. So we'll find these first, and then we'll be able to find acceleration using our mass. Okay? Now, F1 is 100 newtons. Fx, Fy, those will be 100 times the cosine of 30 and 100 times the sine of 30. So let's get rid of this so that we can have some room to work. Well, let's calculate those. So my Fx is going to be equal to 86.6. My F in Y will be equal to 50. And now for force of gravity. You should be able to see now why we're using 10, because the force of gravity here, this is really the force coming down this way. Force of gravity will be equal to mass times the acceleration due to gravity, which would be an acceleration. That's an application of Newton's second law, which is 9.8, which is nice and close to 10. So that's why we were using 10 the whole time. So let's go 15 times 9.8. Now that we know Newton's second law, we can go ahead and use that. That's going to be 147 newtons. Great. And then force normal. Remember, this is going to be my negative force of gravity minus my force in Y, which will give me 97. Let's put the proper negative sign on that force of gravity. And then force of friction. What is that going to be? Well, that's going to be my Fn times my mu k, which in this problem is 0.25. 97 times 0.25, and that gives me 24.25. My F net will be equal to my Fx plus my force of friction. That gives me 62.35. All right, that's in newtons, so that's my net force. So now I can use my mass, 15, to find my acceleration. I'm going to take my F net divided by my mass. I'm going to take my F net it's going to be 62.35 divided by 15, and that gets me 4.2 meters per second squared. 4.2 meters per second squared. Now, if I wanted to look at, let's say, how far that's going to travel from rest in 15 seconds, well, I could say, hey, I've got those kinematic equations. And so x naught would be 0, v naught t would be 0 because we're starting from rest, and I'm going to have 1/2 of my acceleration times that 15 seconds. And I get an answer of 400 72.5 meters. So we're now able to bridge that gap between our dynamics and our kinematics.